So now we discuss the various methods of surface finish measurement. So can generally divide into two types, contact and non-contact. In contact, this is the most popular. There's a stylus which comes into contact with the surface being measured. For this in non-contact, obviously, mainly it is optical. Though they're having some attempts to use surface film or schematic transducers, etc. So, but the practical method is only based on optical instruments. So, optical, again, there are two principles used. One is just scattering. You shine a light onto the surface, say a laser, and how much it scatters. So, that is a measure of the brightness. So, that is one approach. The other is optically, we can measure the heights using interferometry. So that is some of the latest instruments are based on that. So scattering called gloss meters are not used. They don't correlate with the functions on engineering. So let's say they're not really useful. But it may be useful for some applications like your decorative applications, etc. So is this finished good from the customer point of view or consumer point of view? Whether we will identify or we will thin the surface finish that, etc. So that such things this is okay, but for engineering applications, not of much use. So the most popular is the stylus instrument. So in that we basically have a stylus which can go up and down, and those up and down motions are captured by a transducer. So at what position the stylus is measured by a usually an LVDT type transducer. Sometimes capacity is also there. So some different companies use different approaches. And then this stylus is pulled from one end to the other end. So as it traverses the surface, the stylus goes up and down, and the position of the stylus is noted, is converted to an electrical signal, and then that is digitized. So at every small distance of traverse, what is the height is measured, and we get a set of digitized points. This is analyzed using we call it a microprocessor, because there will not be monitor and all. So microprocessor analyzes or computes the various parameters of from the digitized data. So the stylus mechanism is shown here. So the stylus is swinging over it can oscillate over a knife edge up and down. So the stylus is suspended over ligaments. And as the stylus goes up and down, so this armature also goes down and up, changing the voltage generated in the coil and thus measuring the position of the stylus. So this is the mechanism of the stylus. So the stylus instrument. So we have a column over which the drive unit is attached, and in the drive unit we have the probe. So the drive unit moves the probe forward or backward, and on the probe we have the stylus. So this is the basic structure. And of course, in portable units, this column base will not be there. You just have the drive unit attached to a sort of holder box which holds the drive unit. So this is one of the common types of instruments with base and column. So here we have the probe, and The stylus is here. This part is the detector. So the portable system, so it's quite small. So with our metrology lab, we have both equipment. Other one, column type. So this is the instrument, and here we have the detector which moves, or probe which moves forward and backward inside this. And then we have even more portable. You can take in your hand and onto the shop floor easily. So you can keep the entire thing on the machine and whatever piece in the machine. Successes in miniaturization. So okay, this one may cost around just 1 lakh or so. That's the portable one. This one may cost around 5 lakhs. This one, 7-8 lakhs. Different models are there, so just approximately. So you can get this sort of, even there are some Chinese makes for 50,000, etc. So they are very cheap. Whereas the next method is a little costly instrument. So that is based, most popular method is based on coherence scanning interferometry. So we have already learned interferometry, so displacement instrument, interferometers and all. So the light source is focused and made to follow a illumination beam splitter, where part of it goes down. So interferometer beam splitter. So from here, part of it goes back, and other part goes down, is reflected back from the workpiece. So the path difference between the two, that results in interference, and at different portions of the surface, so we'll have different heights. So accordingly, based on the interference pattern, and you adjust this vertically. So using a scanner, you move this beam splitter vertically, and from that we decide the heights. You can identify the heights of various points over the entire surface at a time. So that's the advantage of this type of instrument. So it's quite fast. So only the time to scan up and down. So a certain distance it has to scan, so that, so only when it is in, so then only you can measure the height. So how much is the height difference between different points is measured using that. So of course, we need a computer to do all those calculations. You can't manually see anything. So the entire surface is divided into a certain number of pixels, and in each pixel, what is the height is measured by this system. So this is for coherence scan interferometry. So you have to scan also, slightly scanning, but it's not scanning the entire surface, but only a certain distance vertically, so that it's sort of focusing at various points to get the height at each point. So, for example, this is another type of instrument. So there are Hobson CCI-HD. So HD stands for high density. So the resolution of the area. So CCI is Coherence correlation interferometry. So this is one of those models. So basically, I think it is not offered this Taylor Hobson has been taken over by another company called Anantech. So now I find this model is removed from the production range. So because I think Anantech has another company called Zygo, who also makes this surface finish machine instruments using the same Coherence correlation interferometry principle. Okay, so this is the output from the surface, the instrument we seen earlier. So this sometime back I had taken a sample to Bangalore and got it measured there. So this is actually a turned surface. So they are very flat and you can see the tool path over this. Okay, so this is the path of the cutting tool as it is working. So they using the computer, they make it flat. Okay, subtracting the radius, etc. This helps. So so this is data object CCI-HD. Few years back, I listed the commitment of this. So we were thinking of buying this. So the next principle is based on focus variation. So because imagine a camera which is trying to focus various objects in the distance. So when the tree is in focus, so we can identify that it is at 5 meter distance. When the car is in focus, we can identify that this is at 9 meter distance. So by adjusting the focus, by position of the lens and focusing the various regions, we can identify. So whenever it is in focus, we can identify the height of that portion. So then we can combine all that to get the heights of say 5 meter, 9 meter, etc. So that is the idea of focus variation. So a few years back, we have purchased this Alicona Infinitefocus G5. So I don't know whether you have seen it or not. So this is the okay. There we have a rotary table also on which you can keep the workpiece, and the workpiece can be rotated. We have various objectives which we can change for different magnifications. But then the image is captured by its focus variation. So infinite focus. So this focus variation instrument is promoted by Alicona. Alicona has now been taken over by Broker. So Broker is another manufacturer scanning electron microscopes, trigonometers, etc. So they have taken over this Alicona. So this instrument is there in our advanced microscopy lab. Where we have also the Broker trigonometer. So the sample image from this instrument is shown here. So the range of the instrument is much better. So we can measure even small objects like this, the height of the object. So in order to save time, we are not measuring the entire area. So we skip some of the area and we get this various heights of the surface. Which if you want, we can capture the entire area. Of course, we can capture small portions in different portions and stitch them together. All that is possible in software. Okay, so the range of this focus variation, it can be used to measure even small distances. So that can be used for not only surface measurement, but even measuring objects, steps, etc. So component measurement, just like a CM. So they have come up with a micro CM also. Alicona micro CM they have come up with. So which is possible to measure the heights of various points on the workpiece surface. Then atomic force microscopy. So okay, once again, it is based on the force between the tip and the surface. So you have to move the tip over the workpiece, and then the force on the tip changes. That is measured. So the tip is fixed on a cantilever, and depending on the force, this laser beam, which is reflected to a photodetector, its position changes depending on the attractive force. This goes up and down, and that is used to get the image. So that is the idea of atomic force microscope. So by scanning over the entire surface, we can get. So this is an atomic force microscope. Okay, I think this is some. I think Vico also. It's Hyderabad also. That photo is from there. So sample image. So this is a famous image from IBM. So where we can see atomic level regularities. So you can see some such things can be noticed. So you can see that here that's some restrictions complete. So atomic force microscope is able to obtain very high resolution. Atomic level resolution is possible. Because we can reduce the resolution and get our surface finish parameters as desired by us. So the different instruments have different operating regimes. So the range of operation. So the most sensitive is of course the atomic force microscope. Can start from wavelength of 10 nanometers is the resolution. So very fine resolution is possible. Up to say 100 micrometers. So this is millimeter, micrometer, millimeter. So up to 100 micrometers, atomic force is possible, and amplitude, the height, up to say 1 micrometer is possible. So lower amplitude, lower wavelength, atomic force is sensitive. Whereas for large amplitudes, so 10 mm to wavelength of 100 mm. So suppose extreme conditions, Stylus instrument is possible. Up to say 10 microns wavelength and amplitude again 10 microns. So this sort of range is possible in the Stylus type instrument. And optical type, so low amplitude, no problem. The wavelength is somewhere in between. So large range surface order, etc. The optical instrument, that is the interferometer type instrument or focus variation type instrument, is not suitable. So focus variation is also can be considered an optical instrument because it has a camera and tries to focus. So these are the operating ranges of the different types of instruments. So for casting and all, what instrument will you choose? So casting will be very rough, surface will be very rough. So only Stylus type instrument can be used. If you want to find out atomic level defects, only atomic force microscope is suitable. So that is about the methods. Then, so SCSE, the difference between roughness, heaviness, and form error is